To mathematics students helper. This channel is created for students who want to learn mathematics. Please like this channel, share it to your friend, and also subscribe this channel and request your friends to subscribe this channel.
Now I discuss about the relation on a set. At first, I define relation on two non-empty sets. Suppose S and T are two non-empty subsets. Then any relation between S and T is a non-empty subset of Cartesian product between S and T. That is, if rho is a subset of S cross T, then rho is called a relation between S and T. Now we understand this definition by example. For example, if we take S as 1, 2, 3, T as A, B, then S cross T has 6 elements, 3 into 2, that is S cross T is 1A, 2A, 3A, 1B, 2B and 3B. Any subset of S cross T, is called relation between S and T. For example, if we take rho equal to 1A, 3A, 3B, this is a relation between S cross T. Now I discuss relation on one set. For example, if we take a non-empty set S, if we take a non-empty set on a set, if we take a non-empty set S, then a relation on S is a subset of S cross A. For example, if S equal to 1 to 3, then S cross S contains 9 elements. The elements are 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2 and 3, 3. Any subset of S cross S, non-empty subset of S cross S is a mapping. For example, if we take rho equal to 1, 1, 2, 2, 1, 2, 1, 3, this is a relation on S. Now, suppose A, B belongs to S. Suppose A, B belongs to S, then there are two case arrays. Case 1, A, B belong to row. Case 2, A, B does not belong to row. In first case, we say that A is related with B, and in second case, we say that A is not related with B. A is related with B if A B belongs to row, and symbolically we write A row B. If A, B product element does not belong to row, then we write A is not related with B. A is not related with B, and we write it symbolically. A is not related with B. Or if the relation is R, capital R, in the place of row, then we write A, R, B, and in that case we write A, not a B, is not related with B. Now I discuss three type of relations. Number one, reflexive. What is this? The definition: relation row is said to be reflexive if every order pair element A, that is, two components are equal, must belong to row, for all A belongs to S. If A belongs to S, then order pair A, A must belong to row. Then we say that the relation row is reflexive. For example, if we take A is equal to 1, 2, 3 and row equal to 1, 1, 2, 2, 3, 3 and 1, then this is a reflexive relation. Minimum requirement to be a reflexive relation in that case is 1, 1, 2, 2, 3, 3. There may or may not another elements. We are not interested about this. The minimum requirement is 1, 1, 2, 2, 3, 3. If at least one of these three elements is absent, then we say that the relation is not reflexive. Now we define another type of relation. This is called symmetric relation. The relation says that if AB belongs to row implies that BA belongs to row where AB belongs to S. This type of relation says that if we find if we find any pair element A belongs to S, then there must be BA belongs to row. If AB does not belongs to row, then we are not interested to find BA. For example, the previous example, if we take A is equal to 1 to 3 and row equal to 1 to 2, 1. This is a symmetric relation because 1 to belong to row and 2, 1 belongs to row. But if we take the relation as 1, 2, 2, 1 and 1, 3, then this is not a symmetric relation. Why? Because here 1, 3 belong to row, but 3, 1 does not belong to row. So this is not symmetric relation. If you write 3, 1, then it will be symmetric. And here we can also add 1, 1, 2, 2. This relation will be symmetric. Is the relation is reflexive? No, the answer is not, because here the order pair 3, 3 does not belong to row. Therefore, this is not reflexive relation, but it is symmetric relation. Now I discuss about another type of relation. This is transitive relation. Transitive relation. If there are three elements AB such that AB belongs to row, BC belongs to row, and if we can find another element AC, then we show that then we can say that the relation is transitive. AB, BC. Therefore, AC must belongs to row. First, second belongs to row, second, third belongs to row. Therefore, AC must belongs to row. This is transitive relation. We explain this by example. If we take same example 1, 2, 3 and row as 1, 2, 2, 3, 1, 3, 1, 1. This is transitive relation because here 1, 2 belongs to row, 2, 3 belongs to row. Therefore, second, third vanish, first, third. 1, 3 belongs to that. But if we write here another element 3, 1, then this is not transitive because here 2, 3 and 3, 1 belong to row. Second, first cancel and first and third, that is 2, 1. Here 2, 1 does not belong to row. Therefore, this is not a transitive relation. Therefore, three type of relations exist. These are independent. There are many relations which are reflexive but not symmetric transitive. Another relation reflexive and symmetric but not transitive. There are many type of examples. If a relation is reflexive, symmetric and transitive, then the relation is called equivalence relation. Equivalence relation or RST relation. R for reflexive, S for transitive, T for R for reflexive, S for transitive, S for symmetric and T for transitive. Okay. So reflexive is if for any element A in S, the order pair A comma A belongs to row, then we say that the relation is reflexive. If for any elements A B belongs to row, then B A belongs to row, then we say that the relation is symmetric. The symmetry means interchanging the place of A and place of B are interchanged. Next is transitive. This says that if AB belongs to row and BC belongs to row, then AC belongs to row. That is, in the first relation B cancel out, in the second relation B cancel out. Therefore, first and third, that is A and C is written. In that case, the relation is called transitive. Now, I give some example to understand the results. Here I write down some examples. The set is A is equal to 1, 2, 3. Row 1 equal to 1, 1, 2, 2, 1, 3, 3, 1. 2, 3. Here I give 3 examples. Now we have to check either these relations are reflexive, symmetric or transitive. If the relations are reflexive, symmetric and transitive, then the relation must be equivalent relation. At first, number 1, we check because here 1 1 2 2 belong to row, but 3 3 does not belongs to row. Now this is not reflexive. This is not reflexive. Number 1. This is symmetric? The answer is no, because here 1 3 belong and 3 1 belongs, there is no problem, but 2 3 belong to row 1, but here 3 2 does not belong to row. Therefore this is not symmetric. Is this transitive? The answer is no, because here 1 3 belongs to row 1, 3 1 belongs to row 1, therefore 1 1 have to belong to row 1, this is present, no problem. But here 2 3 belongs to row 1 and 3 1 belongs to row 1. According to transitive property, if 2 3 and 3 1 belong to row 1, therefore 2 1 must belong to row 1. Therefore here 2 1 does not belong to row 1, therefore this is not a transitive relation. Therefore this is not transitive. Number 2. Is this reflexive? The answer is yes, because here 1 1 2 2 and 3 3 all are belong to row 2. Therefore this is reflexive. Is this symmetric? The answer is yes. Here 1 2 is present in row 2, therefore 2 1 is also present, 3 1 present and 1 3 present. Therefore if we interchange the place of the element in every pair, therefore these are all belong to row 2. Therefore this is symmetric. Is this transitive? Here 1 2 2 1, this is cancelled, therefore 1 1 this belong to row 2, 3 1 1 3, this is cancelled, 3 3 belongs to row 2. So 1 3, this is I hope that this is transitive. I hope that this is transitive. No, this is not transitive, because here 2 1 1 3 belong, 2 1 and 1 3. If this is transitive, therefore then this is cancelled, therefore 2 3. Now after 2 3 have to belong to row 2, but here 2 3 does not belong to row 2. Therefore this is not transitive relation. Number 3. This is not reflexive, because 1 1 belong to 1 1 2 2 belong to row 3, but 3 3 does not belong to row 3. Is this symmetric? The answer is yes, symmetric. But this is not transitive, because I will repeat 2 times. This is symmetric but not transitive. This is not reflexive. This is symmetric but not transitive. Why? Here 3 1 1 3 both belong to row 3, but 3 3, but this cancel out, therefore 3 3. Now after 3 3 have to belong to row 3, but this not happen in that case, therefore this relation is not transitive. Therefore these are examples of different type of relations which are reflexive or not, symmetric or not, and transitive or not. Now I give another example to describe the relation. Suppose this is the set of all natural number, that is 1 2 3 like this, and row such that AB greater than 0. We have to check that is the relation reflexive, symmetric or transitive. If this is reflexive, symmetric and transitive, then it will be equivalence relation or RST relation. At first, I check reflexivity. At first, I check is the relation reflexive or not. For this, we take an element A belongs to S. Since A into A equal to A square greater 0, therefore A is related with A. Therefore, this is a reflexive relation. This is a reflexive relation. Rho is reflexive relation. Now, I discussed about symmetry property. For this, we have to choose two elements A and B in S. We have to choose two elements A, B in N such that A is related with B. That is, A greater than 0. We have to check either B is related with A or not. That is B product A greater 0. Students, you can see that AB greater 0 implies that BA greater 0. Therefore, B is related with A. Therefore, the relation is symmetric. Therefore, rho is symmetric. Now, I discuss about the transitivity. For this, I take three elements. This is transitive. We take three elements A, B, C in N such that A is related with B and B is related with C. Now I have to check that is A is related with C or not. If A is related with C, then I have to show that AC greater than 0. If we can show that AC greater than 0, then A is related with C. What is the process? If A is related with B, then we can see that AB greater than 0 and BC greater than 0. Implies that A B square C greater than 0. We product that two inequalities. That implies that AC greater than 0 since B square greater than 0. Hence for A, B, C in N, A related B, B is related with C implies that A is related with C. Therefore, the relation rho is transitive. Relation rho is transitive. What happens? Now, what happens if in that case the relation is equivalence relation because it is reflexive, symmetric and transitive. Now our question, what happens if we take set of integer in the place of set of natural number? That is, if we take z, then z is 0, plus minus 1, plus minus 2, plus minus 3, dot 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 dot. And same definition. Friends, so that this is not symmetric. Sorry. This is not reflexive because here 0 into 0 equal to 0, not greater than 0. Therefore, this is not reflexive. Symmetric. This is symmetric. You can proceed in the previous way. Transitive case, I discuss this. Same as previous problem, we take three elements A, B, C in Z such that A is related with B and B is related with C. Now I have to check either A is related with C or not. For this, it implies that AB greater than 0, BC greater than 0, implies that AB square C greater than 0, implies that AC greater than 0 if B square greater than 0. If. Therefore, I have to check that is B square is positive or not. The students, you can see that B square cannot be negative, but it can be 0. Since we take the set of integers, therefore B square may be 0. If we take B equal to 0, then then BC is not necessarily greater than 0. That is, therefore BC is not, is AC. AC is not always greater than or equal to 0. AC is not always greater than 0. For example, 1 is related with 0, 0 is related with minus 3. But 1 is not related with minus 3 since 1 dot minus 3 negative. Therefore, this is not transitive relation. Now, I discuss another problem. If we unchange the set but we change the relation, that is, if we define relation rho equal to AB such that AB greater than or equal to 0, then this will be reflexive. In previous problem, this was not reflexive because here we take A equal to 0, but here this is reflexive, and you can check that this is symmetric, and this will be transitive, and this is an equivalence relation. So students, today I discuss about relation. So if you have any query, you can mail. The mail is given in my description box. Thank you. Please like, share it to your friend, and obviously subscribe my channel. This channel is created for you and your friends to solve your problem. Thank you.